In the last couple of videos, we already see what one of the major issues is when we're finding these zeros of polynomial functions, and that is your long list of possible rational roots. So here we're going to give you a way to kind of eliminate some of those values. It says in many cases, and this is called Descartes' Rule of Signs, in many cases the following rule, discovered by the French philosopher and mathematician René Descartes around 1637, which is actually a pretty modern discovery if it's in the last 400 years, is helpful for eliminating possible zeros from a lengthy list of possible rational roots. To understand this rule, first we must look at variations in signs in a polynomial function. When a polynomial function is written in standard form, which reminder, standard form is highest power down to lowest power. A variation in signs occurs when consecutive coefficients have opposite signs. So this will be pretty easy to find. When you go from a negative to a positive or a positive to a negative, then you have a sign change. So how many variations in signs does the function below have? So you started with positive and you see a sign change here, positive to a negative, and then it changes back to a positive. Then it stays positive, and then here you change from positive to a negative. So that would be actually 3 sign changes. So just anytime you change from positive to negative or negative to positive. So here's what the actual rule says. Given a polynomial function is written in standard form with real coefficients, the number of positive real zeros. So how many positive answers are you going to have? How many positive real values are going to be zeros to this function? The number of positive real zero will always equal the number of variations in signs of f of x, or less that by an even number. And what is that? What in the world is that whole less than that by an even number mean? Well, you might have 7, or you might have 5, or you might have 3, or you might have 1. Notice I went down 2 each time, so it doesn't tell you exactly how many you have. It tells how many you might have. Or if you have 8, then it might be 8, or 6, or 4, or 2, or 0. So either this number or less than that by an even number. The number of negative answers is equal to the number of variations in signs of f of negative x. Remember, we found f of negative x when we were finding out if a function's even or odd and all that, or less than that by an even number. So kind of the same scenario as up here. With Descartes' rule of signs, repeated zeros are included. Therefore, a zero with a multiplicity of m is counted as m zeros. Remember that. Keep that in mind. So let's start with number 1. State the possible numbers of positive and negative real zeros. So let's start out with f of x. Actually, let's go ahead and find f of negative x, just to remind you. Something we do need to remember, negative x to the powers. If you were to take, and that needs to be on the outside. If you were to take negative x and raise them to different powers, a negative times a negative gets rid of that negative. However, a negative times a negative times a negative keeps the negative. So anytime you raise negative x to an even power, you lose the negative. Anytime you raise negative x to an odd power like 5, you keep the negative. So therefore, let's find f of negative x here. So that'd be 2 times negative x to the third minus negative x to the second plus 2 times negative x plus 1. Let's clean that up. Here you're going to keep the negative, so that'd be negative 2x to the third. Here you're going to lose it, so bring down this negative, and that'd be x to the second. Positive times a negative would be a negative, and then I lost my plus 1, so there we go. There's f of negative x. So let's start out with the sign changes for f of x. You start positive, and then you go negative. There's one sign changed. Then you go from negative to positive. There's another sign change. So that is 2 sign changes. What does that mean? How many positive real zeros do you have? Since there was 2 sign changes in f of x, you'll either have 2 or 0. You start with how many sign changes you have, and then you subtract 2, and if you need to, subtract 2 again. So you're either going to have 2 positive or 0 positive real solutions here. How many negatives do I have? I don't know. Let's look at f of negative x, and that tells you how many negatives you're going to have. Okay, you start with negative 2x to the third, then you go to negative x to the second, then you go to negative 2x. So there's no sign changes yet, but right here you change to a positive, so there is 1. There is going to be 1 negative. Now, notice I didn't subtract 2 because I can't do or negative 1. You can't have negative 1 zeros. So therefore, there is 1 negative real 0 here. So that is all your possibilities. So what does this even help? Okay. What if you found out, you went through your list and you found a negative? Guess what? None of the rest of them, you could throw the rest of the negatives out because you found the only negative. Now you can start searching for positives. Okay. Number 2, step number 1, let's find f of negative x. We're going to here, when you plug in negative x, you're going to keep the negative. So I'm just, instead of going through the whole process, I'm just going to do it. When you raise it to the second power, you're going to lose the negative. So that'd be negative 17x squared plus 10. That's going to be f of negative x. So now let's find the possible number of positives and negatives solutions. So let's look at our sign changes of f of x. You have a positive and it changes to a negative here, and it changes back to a positive here. So there are 2 sign changes. So how many positive solutions do I have? I'll have either 2 or 2 minus 2, which is 0. Positive zeros for this function. Now how many am I looking for? I'm looking for 3 total. So 2 of them or 0 of them are going to be positive. So I bet one of them is going to be negative. Let's see. You go from negative, you stay negative, and then you go to positive. So that's your only sign change. So you have 1 negative 0 there. Number 3, you have f of x. Let's find first off f of negative x. When you raise negative x to the 4th power, you lose that negative. When you raise negative x to the 3rd, you keep the negative. So you have a positive times a negative. That'd be a negative 21x to the 3rd plus the 27. So let's look now at sign changes. Let's start with the f of x. You have a positive, still a positive, still a positive. So no, none. There's no sign changes. So there will be no positive zeros. And if you go back and remember, we did work a problem to where we had all positive values here when we were doing synthetic division. And I told you, if this out here is a positive, how in the world can you bring these down and get a 0 here? It's not going to be possible. So there's no positives. Now let's check negatives. You have a positive, a negative, which there's 1 sign change, and then a positive, there's another sign change. So since there are 2's, I will have either 2 or 0. Subtract 2 from it, negative roots. Number 4. And I've done that for you. Notice that here you kept the negatives, and maybe here you dropped the negatives, so the 2 stayed negative. You didn't have a negative times a negative. Now let's see how many positive and negative solutions am I going to have as a result of this. So let's start with f of x. You start with a positive, and there is 1 sign change. You go to a negative. There is 2 sign changes, 3 sign changes. You stay negative here, and there are 4 sign changes there. So therefore, you will have either 4 positive roots, or go down 2, or go down 2. You might have 4, or 2, or 1. Now let's check out our negatives. You start negative, you stay negative, you stay, you change here. So therefore, you're going to have 1 negative. And you might be saying, well, what about the other ones? What if I have 2 and 1? What are the other 2 going to be? You do have some imaginary roots that we will be discussing a little bit later in the chapter. Here, first step, let's find f of negative x. And there you see f of negative x. And you'll get into the habit of what actually happens when you find f of negative x. Again, all of your even powers are going to stay. All of your odd powers, the positives will change to negatives and the negatives will change to positives. So that's what happens on those. So how many sign changes do I have? F of x starts negative, changes to positive. There's 1. Then it changes back to negative, then it changes back to positive. So you have 3. So how many positive zeros will I have? Either 3 or 1. How many negative sign changes do I have? It's negative, negative, changes to positive. There's 1. So I have only 1 sign change. Number 6. Now something I noticed right off the bat with 6 is there's not a constant term. So automatically you're going to have one 0 that's going to be 0 because that 0 or that x value could be factored out. So you could do that first. You could factor that if you'd like. But I am going to go ahead and find f of negative x like it is. And with that done, let's look for sign changes. Here you have a negative that changed to a positive. So you have only one sign change. And here you have a negative that stays negative. So you have 0 sign changes there. So there's not going to be negative solutions. So it looks to be like you're going to have one positive. One of my solutions I already know is going to be 0, and the other 2 will be complex or imaginary solutions. Okay, number 7. Here I found f of negative x, and let's determine how many positive or negative solutions. A positive, positive, positive. Here's my first sign change, my second and my third sign changes. There are 3, or go down 2. There's going to be either 3 or 1 solution. That's going to be positive. You start negative here, you go positive, there's 1, negative, there's 2, and it stays negative. So therefore you have either 2 or no negative solutions or negative zeros here. And the last one of these, number 8, there's f of x. Let's find f of negative x. So there is f of negative x. Let's start out with our positive. How many positive roots will we have? So how many sign changes do we have here? Starts negative, goes positive. There is 1, and it stays. So you have 1 positive root. Now let's look at negative. It starts positive, stays positive, it changes signs there, and then once again, so either 2 or 0 sign changes there. So therefore 2 or 0 negative roots. Okay, on the next section it says create our list of possible rational zeros, then find all the zeros. And we're going to use Descartes' Rule of Signs to help us to eliminate possibilities. Let's first off start off by listing all of our possible rational roots to this function. And there those are. Next up, we're going to find f of negative x, and we're going to see how many positive roots and how many negative roots might we have. So f of negative x is going to be this. So there you see your f of x and f of negative x. Let's look for sign changes. I have 1 there, and that's it. So that means I'm going to have 1 positive root. And negatives, I have a sign change here, here, and here. So I'm having either 3 or 1 negative root. So here's all my possible rational roots and how many of each I'm going to have. So now let's go through our list and start trying to find one that does work. So here is where I've actually tested 1, and we see that 1 is going to be a root. So what does that tell us? 1 is a positive number, and we have only 1 positive root. And this is going to be it. That's the only one. So what we can actually do now is we can go through and we can eliminate every other positive root. So that shows you that what we have left is either negative 1, negative 2, negative 4, or negative 8. So that narrows down our list of what to try. So our new function is now f of x is equal to, since we divided by x minus 1, so we can now simplify this into x minus 1 times x to the third plus 7x squared plus 14x plus 8. And as I'm trying to simplify this, again, you don't have to worry about 1, 2, 4, and 8, only the negative 2, negative 1, negative 4, negative 8. Now let's try to find one of those that'll work to simplify that. So from that list, I now tested negative 1. Negative 1 did work, so I broke this down now into x minus 1 times, this is now x plus 1 times x squared plus 6x plus 8. And then I can now simplify that down by simple factoring. That's going to be x minus 1, x plus 1, and this will break down into adds to give you 6, multiplies to give you an 8, would be a positive 2 and a positive 4. So my zeros are going to be 1, -1, -2, and -4. Number 10. Again, let's start out by listing all of our possible rational roots. I'll do this over to the side. So here's my list of possible rational roots. Now let's find f of -x. And let's compare it, sign changes to figure out how many positive solutions and how many negative solutions I'm going to have. So there we see f of x and f of -x. Let's look for sign changes. There are none, so there are no positive sign changes. So therefore, there are no positive roots. Negative sign changes, I have 1, 2, 3 there, and 4 there. So that means I'm going to have either 4 or 2 or 0 negative solutions. So that helps us out from the very get-go because I have no positive answers. So I can actually go ahead and cross out +1, +2, +4, and +1/2, and I have 4, 2, or 0. So there's a great possibility that the first thing that I try, either -1, -2, -4, -1/2, is probably going to work. Okay, so I tested -2, and -2 did come out to be a remainder of 0. So therefore, I've now broken my original function into x plus 2 times 2x to the third, this stuff, plus 11x to the second, plus 9x plus 2. Now, what I've got left, what I suggest doing is going through and actually revamping my list because now I no longer have a 4 at the end, I have a +2 at the end. So now my possible rational roots will be all the factors of 2 over all the factors of 2. So if you look at now your possible rational roots, you can actually eliminate the -4. You know it's not going to, so it either has to be -1, -2, or -1/2. So let's try a different one next. Let's actually try -1/2. And reminder that as you try -1/2, that now this is what you're trying to break down, so use those coefficients instead. So here, now you see that -1/2 works because I get a remainder of 0. So now let's rewrite our function again. So we now have x plus 2, bring it down. We divided by x plus 1/2, and we got 2x squared plus 10x plus 4. Now we can factor this by normal methods. Notice that we have a 2 in common that could have actually been factored all the way to the front. And I do like to put those numbers all the way out front whenever you factor them out. So I now have 2 times x plus 2 times x plus 1/2. And this turns this into x squared plus 5x plus 2. Which now factor, we can try to factor it, but it's not going to. Adds to give me 5, multiplies give me 2, that does not exist. So we're now going to have to use either our quadratic formula, or we can use our completing the square there. And I've actually just come over to the side and plugged that in for you. So now my roots, when you set each of these factors equal to 0, you get roots of x equals -2 from here, -1/2 from here, or whenever we solve this by saying it equal to 0, it'll be -5 plus and minus the square root of 17, all divided by 2.